Here's a problem from section 8.1 of Rogowski's Calculus, page 449. Let's look at problem 36. It says compute the surface area of revolution about the x-axis over the interval. So we've got the function y equals 4x plus 3 and the interval 0 to 1. Okay, we're rotating this around the x-axis. So if you think about this line, the intercept is 3 from 0 to 1. Just roughly, this is what we're looking at. We're rotating around this axis. So you can sort of see it's just sort of like a funnel shape. And we're looking at the surface area. Now you remember surface area, the integral there, we're thinking about somehow these slices, right? So the integral is 2 pi r. If you think about it, that's the circumference times the length of one of those slices. So 2 pi r, what's the radius here? Well, the distance between the axis of rotation and the function is in fact the function itself. Okay, and we're going to be slicing from 0 to 1 along the x-axis. And then what you have to have in here is the length of this chunk. So in general, that's the square root of 1 plus the derivative of this squared. Now the derivative of this just happens to be 4, so makes it easy for me. We square it. Okay, so what happens here is you just get 2 pi times the integral from 0 to 1 of 4x plus 3 times the square root of 17. And maybe we should pull the square root of 17 out front. I'll do it in my next step. So I have 2 square root 17 pi. Then I need to integrate this piece in here. Well, 4x integrates to 2x squared. 3 integrates to 3x. I'll evaluate from 0 to 1. So 2 times the root of 17 times pi. Then plugging in a 1 here gives me what? 2 plus 3. Plugging in a 0, you could put in minus 0 here, but you see that it goes away. So that's 5. So probably the simplest answer is 5 times 2 is 10, root 17 pi. There you have it.